Okay, in number 1, we're asked to determine the vector and parametric equations of the plane that contains points. The whole idea of a plane is that you need to have directions, right? So we need to start off by figuring out the directions that are involved in this. So let's do AB. We get 1, -2, and -1. And we could also do AC. We'll get 3, 2, and 0. And now, if I want to make a vector equation, I'll pick a point, any point I want. I'm going to use A. You could use B or C. Totally fine. And we need our direction. So, oops, not -1, 1. Fix that. So 1, -2, -1, and T, 3, 2, and 0. Order doesn't matter, and if you chose to do BC, that would have been fine too. Parametric, well, that would be x equals 1 plus s plus 3t. Y would be 2 minus 2s plus 2t. And z equals 4 minus s. Here's part 1. Part 2, let's figure out the Cartesian. So for our Cartesian, part 2, we need the normal. The normal is made up of your two vectors crossed, right? So s and t. So s is -2, -1, 1, -2, and 2, 0, 3, 2. So we've got 0 minus -2, -3 minus 0, and 2 minus -6. So we've got 2, -3, and 8. So our normal gives us our coefficient, so 2x minus 3y plus 8z plus d equals 0. To get d, we use a point. So we can use the point A that we were given, or B, or C, it doesn't make a difference. And 8 times z, b is 0. We get 28 plus d is 0. So d is -28. So our equation, Cartesian form, 2x minus 3y plus 8z minus 28 is 0. Part B, does the point lie on this plane? Well, if that point lies on this plane, then I should be able to substitute this for x, y, and z, and it should work, right? So let's take our Cartesian and let's try it. So 2 times x, x was 1. That's what we're told up here. Minus 3 times y, y was -1. Plus 8 times z, z was -1/2. Just taking our points, okay. Minus 28 should come out to 0. Let's see what happens. We get 2 plus 3 minus 4 minus 28. Well, obviously that does not come out to 0. I got -27. So this point is not